Hello and welcome to Learn Statistics class. In this class we are going to study the statistical terms in simple and easy way. In this lecture we are going to study the 2 points. First is nature of the data and second one is arithmetic mean denoted by AM, or it is also known as mean only or simple mean. Let us see the first point, nature of the data. According to nature of the data is divided into 3 types. Let us see the first type, individual data. If values of individual items are given, that data is called an individual data. The form of individual data is suppose we are given x1, x2, x3 xn n values. These are the individual data. For example, one, 5, 9, 10, 12, 13, 15, etc. Here the separate values are given, hence this data is a individual data. Now let us see the second type, discrete data. If only discrete or distinct values and their frequencies are given, that data is called discrete data. The form of discrete frequency distribution is as follows. Suppose we are given the values x1, x2, x3 xn with frequencies say f1, f2, f2, f3, likewise fn. Then the discrete data can be expressed in the tabular form as given below. Suppose we are given the values of x as x1, x2 xn with frequencies f1, f2 fn. Here n is the sum of frequencies summation fi. Here the letter summation is denoted by Greek letter sigma. For example, let us see one example to understand the discrete data. Suppose we are given the values as 0, 1, 2, 3, 4 and 5 with their corresponding frequencies, say 2, 10, 46, 62, 47 and 20. This n is the total of all frequencies and it comes out to be 18. In discrete frequency distribution, how many times a particular value is repeated is counted. Hence, the values of x along with their frequency is called a discrete data. Now let us see the next type, continuous or grouped data. In continuous or grouped data, if different classes and their frequencies are given, then that data is called continuous or grouped data. The form of continuous or grouped frequency distribution is as follows. Here the values are grouped into different classes and the number of values falling in a particular class is counted. Now let us see one example to understand the continuous or grouped data. Suppose we have given the groups or classes as 0 to 10, 10, 20, 20, 30, 30, 40, 40, 50, etc. All these are the classes and their corresponding frequencies are say 1, 4, 5, 6, 3, etc. Here n is the total of all these classes, which is comes out to be 19. This data is called a continuous or grouped data since the values are classified into groups. For example, 0 to 10 means in the class 0 to 10 there are one value only. So the frequency of class 0 to 10 is 1 and value falling in class 10 to 20 is 4. So its frequency is 4. Likewise, there are 3 values in the class 40 to 50, hence the frequency is 3. Now let us come to the next point, arithmetic mean or simple mean. Let us see the definition of arithmetic mean. Arithmetic mean is denoted by AM or it is also known as a simple mean. Arithmetic mean of a set of observations is defined as the sum of all observations divided by the total number of observations. It is denoted by x bar. Thus, if we are given an individual data that we have seen in the previous slides, that is, if we have given the values as x1, x2, xn, individual data, then the arithmetic mean is defined as x bar is equal to sum of all these values, means x1 plus x2 plus x3 plus dot 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 up to xn. Since there are n values we have given, it is divided by n. It can be written as 1 upon n sigma xi, I is running from 1 to n. Here the letter sigma is a Greek letter used to denote sum of observation, and this is the limit from 1 to n. Suppose if we are given a discrete frequency distribution with values x1, x2 dot dot xn. As we know that in discrete frequency distribution we have discrete values and their frequencies, and frequencies f1 f2 dot dot fn. Then the arithmetic mean is defined as x bar equal to multiply the frequency with their value and then add f1 x1 f2 x2 plus dot 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 plus fn xn divided by, we have given the values, total values f1 plus f2 plus dot dot fn. This can be expressed in the form of summation as summation fi into xi, I is from 1 to n, divided by sum of frequency. This sum of frequency can be written as a capital N this is the formula for arithmetic mean in discrete data. Now let us see how we calculate the arithmetic mean in grouped data. If different classes and corresponding frequencies are given, that is, if we are given continuous or grouped data, then calculate the midpoints of the classes. The midpoints, how we calculate the midpoints of the classes? Midpoint of a class equal to lower limit of a class plus upper limit of a class divided by 2. Suppose if M1, M2, M3 and Mn are the midpoints of the classes with frequencies, say f1, f2 dot dot fn are given, then the arithmetic mean is defined as x bar equal to f1 into m1 f2 n2 plus dot 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 fn into man divided by f1 plus f2 plus dot 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 fn, which can be expressed in the form of summation as sigma fi multiplied by mi divided by sigma of fi. This can be written as 1 upon n summation I equal to 1 to n fi mi. This is the formula for continuous data. This is the formula for arithmetic mean for the continuous data. Arithmetic mean formula differs as the data differs, means arithmetic mean for individual data there is a different formula. For discrete and continuous data the formula changes. Now to understand all these formulae, let us see the examples on arithmetic mean. Consider the first example for the individual data. calculate the arithmetic mean of scores of 12 students in a class test. The score of students are 15, 9, 18, 20, 21, 26, 14, 13, 27, 17. All these values are separate and individuals. Hence, the given data is a individual data. So, in order to calculate the arithmetic mean, in this example, we have to use the formula of arithmetic mean for individual data. Here, solution. The total number of observations are 12 given since there are 12 students. And the formula for mean is x bar equal to summation xi upon n. That is, we have to add all these values divided by the total number of observations 12. If we add all these values, we will get the sum 218 divided by 12. Divide 218 by 12, we get the arithmetic mean as 18.1666. This is how we calculate the arithmetic mean in individual data. Only we add the individual values and divide by the total number of observation. Then we will get the arithmetic mean for individual data. Now let us see how we calculate the arithmetic mean in discrete data. Consider the example. Calculate the arithmetic mean from the following data. Here we have given the values x as 0, 1, 2, 3, 4, 5, 6, 7, 8 with their corresponding frequencies like 2, 10, 46, etc. ... 2. Since values and frequencies are given, the given data is discrete. So here we have to use the formula of arithmetic mean for discrete data only. Now let us prepare a table. Write all these values in a tabular form as x 0, 1, 2, 3, 4, 5, 6, 7 and 8. Corresponding frequencies f 2, 10, 46, 62, 47, 20, 5, 2 and 2. We know that the formula for a discrete distribution is x bar equal to summation f into x divided by capital N. Now let us prepare a calculation table as values and frequencies. Add all these frequencies to get the value of N, and which comes out to be 196. Then the next column we have to prepare is f multiplied by x. So these values are 0, 10, 92, 186, 188. How we get this value? 0 into 2, 0, 1 into 10, 10, 2 into 46, 92, 3 into 62, 186. Likewise 4 into 47, 188. Similarly 5 into 20 is 100. Likewise 6 into 5 is 30. 7 into 2 is 7 7 into 2 is 40. 8 into 2 is 16. Add all these values, we will get summation f into x, and which is 636. This is the observation or calculation table. Now put these values in the formula for arithmetic mean of discrete data. What is that? X bar equal to summation fi xi divided by capital N. Summation f into x is from the table 636 and N is 196. Divide it, it comes out to be, after the division, 3.2449. Hence, the mean or arithmetic mean in this example is 3.2449. Now let us learn the arithmetic mean in continuous or grouped data. How to calculate in the grouped data. Consider the example, calculate the arithmetic mean from the following data. Here we have given marks and number of students. Marks are divided into in the classes. For example, marks from 10 to 20, 20 to 30, 30 40, likewise 70 to 80, and the number of students belonging to that class are counted and which are also given, like 4, 18, 22, etc. Since classes and frequency are given, the data is a group or continuous data. In this example, the formula for mean is x bar equal to summation f into mi divided by n, where m is midpoint of the class. We have learned it. Midpoint of the class. We know it how to calculate midpoint. Suppose if we want to calculate the midpoint of first class 10 to 20, then how we calculate it? M1 equal to lower limit 10 plus upper limit 20 divided by 2. How much it is? 30 by 2, and which comes out to be 15. Means the midpoint of first class 10 to 20 comes out to be 15. Let us prepare a calculation table. Write down the marks and number of students in a tabular form and write the total of frequency. If we add all this frequency, it comes out to be 100. Prepare a next column, midpoint, denote it as M, and next is frequency into midpoint. Now we will write the midpoints. We have seen the first midpoint comes out to be 15. Now second midpoint is 20 plus 30 upon 2, means 50 upon 2, it comes out to be 25. Similarly 30 plus 40 by 2 means 70 by 2, it comes out to be 35. Likewise calculate all the midpoints as 45, 55, 65 and 75. Multiply these values, midpoints, with frequency. For example, multiply 4 into 15, we will get 60. Next, multiply 18 by 25, 450. Likewise, 770. And last one is multiply 3 by 75, which comes out to be 225. Add all these values, we will get the sum of frequency into sum of multiplication of frequency into midpoints, and which comes out to be 4280. Put all these values in the formula of arithmetic mean for the continuous distribution. We will get the value of arithmetic mean. Hence, we will get arithmetic mean as 42.8. In this lecture, we have learned the nature of data, in which we have studied the nature of three natures of data: individual data, discrete data, and continuous data. And in the next point, types of average, we have learned the arithmetic mean. Arithmetic mean, its definition, and how to calculate the arithmetic mean for individual data, discrete data, and continuous data. In this way, we will stop here and we will meet in the next lecture. Till then, thank you.